M12, eighth question. Let's read the question. It says, a car of mass 1000 kilograms is moving up a hill inclined at 30 degrees to the horizontal. The total resistive force acting on the car is 1000 Newton. Calculate the force applied by the engine, the driving force. They're asking the driving force. Straight away, I came to a difficult question, right? Just easy questions, you can try it on your own. I will maybe discuss them in the tutorial discussions and then post it as well. I'll be analyzing some difficult questions, right? In the class hours. Right. M13, right? M13, eighth problem. Here they're saying a car is moving up an inclined plane. So I'll mark the car as this. So the inclined plane is how much inclined? 30 degrees to the horizontal. First of all, as soon as you read a question, try to put it into the diagram. Try to put it into a diagram, right? So try to understand, guys, right? So in theory, we cover only the required main theory parts. In question discussion, only a lot of extra knowledge is going to be absorbed, right? Okay, so 100% concentration is required. Now, they're saying a car of mass 1000 kilograms, right? Mass is 1000 kilograms. I'll draw this somewhat bigger. Right? This is the mass. How much? 1000 kilograms. 1000 kilograms. Right, 1000 kilograms. What else? They say resistive, when the car is moving upwards, a resistive force will act in which direction? If the car is moving upwards, the resistive forces will be acting in the opposite direction, right? Resistive forces means these frictional forces and other forces, which is a disturbance to the motion. If the car is moving upwards, the resistive forces will move downwards. So therefore, I will mark the resistive forces as this. Resistive forces. So the resistive force is 1000 Newton. 1000 Newton. What they are asking is find the driving force. Find the driving force by the engine. The force supplied by the engine. Initially, when the acceleration is 2 meters per square second. When the acceleration is A equal 2 meters per square second. Now, first of all, if you are asked to mark the free body diagram, what would you do? If you are asked to mark the free body diagram, what would you do? The object is in contact with the surface. This object is in contact with the surface. Therefore, definitely a reaction force is there on the object perpendicular to the surface. Isn't it? This object is in contact with the surface, inclined plane. The object is in contact. Therefore, definitely, this reaction force will be perpendicular to the surface, acting on this object, right? Okay. Right. If this is 30, this is 90, this is 60. Right? Consider this triangle. Consider this triangle. This is 30, this is 90, this is 60. Then this is also 60, vertically opposite angles. Right? This is 90. Therefore, this is 30. If this is 30, right now, guys, one thing, from now onwards, these easier questions and all are not going to be there. Right? From today's session onwards, completely it's A level. Up to now, what we did was like, okay, slightly some O level knowledge was there, and then okay, it was fine. But now things are going to get a bit tricky. So therefore, you need to have an open mind, right? So yes, 30, 90, 60. This is vertically opposite angle 60, 90, 30. 30. So actually, this is where the weight acts. Weight is acting vertically downwards. Vertically downwards. Let us mark the weight mg. M means what? 1000. When you multiply another 10, mg, g is also 10, right? Mg. This is 10,000 Newton. 10,000 Newton. Now, this mg force is acting vertically downward, right? In order to find this force exerted by the engine, in order to find the force exerted by the engine, I need to apply F equal ma along the plane, right? So for the car, F equals ma is applied along the plane, for the car, along the plane. But the thing is, right, F is along the plane, R is also along the plane, fine. But mg is not along the plane. Mg is not along the plane. Mg is vertical. So therefore, what we need to do is, before we apply F equals ma, we need to find all the possible forces acting along the plane. We need to find all the possible forces acting along the plane. Mg is acting vertically downwards. Mg's component will act in this direction. You know, right? If this is Mg, if this is Mg, if we resolve Mg, this is 30 degrees. If we resolve Mg away from the angle, then what is this? Mg sine theta. We have learned how to resolve and all, right, in the first lesson. Yes. What is this? Mg cos theta. Cos 30. When you resolve towards the angle, it is mg cos 30. So therefore, we represent this mg, the mg force, the capital mg force, we are going to represent it. We know, right? We can represent it, like if there is one force, we can represent it by its components. Mg sine 30 and mg cos 30 are the components of mg. So mg venuwata මේ mg cos 30 and mg sin 30 කියලා mark කරන්න පුළුවන්. Right? This is possible. Therefore, what we do is, instead of this mg, we represent mg sin 30. And this is what? mg cos 30. When you, after you represent the mg in mg sin 30 and mg cos 30, this is not going to be there anymore. Make an කියලා ගන්න ඕනේ. හරි? This will not be there anymore. Right? What have you done? You have resolved the weight component. This is how you do inclined motion questions, right? From now onwards, remember, whenever the weight is given, resolve the weight. For the first time, it might be somewhat difficult for you to understand, but when we practice questions, it will be quite easy. Right. The weight is resolved. Right. Now, we can easily apply F equals ma to this object. Let us consider the car. This is the system of car, right? Car system. We're going to apply F equals ma along the plane. What is the upward force? Capital F. Is there any other upward forces? No. What is the downward force? Minus mg sin 30. Also, there is another downward force. What is it? R minus R. Minus R. What about this R? Capital R force. R force is perpendicular to the direction that I apply F equals ma. I'm applying F equals ma in this direction. R is in this direction. I'm applying F equals ma in this direction. R is perpendicular to it. So, when you resolve this R cos 90. Actually, if you resolve this R in the direction where we apply F equals ma, is going to be R cos 90. R cos 90 is 0. R cos 90 is going to be 0. Therefore, it will not come to the equation. It will not come into the equation. This is R naught. Let's assume R naught. R naught is not going to come into the equation because we can't resolve it. Right? Mg cos 30 is also perpendicular to the F equals ma direction. Mg cos 30. So therefore, mass into what is the acceleration? A. If we simplify, F is equal to F minus mg is what? 1000. Sin 30 is what? Sin 30 is half. What is the resistive force? 1000. What is the mass? 1000. What is the acceleration? 2. What is the acceleration? 2. So you have to simplify this. You have to simplify this. If you simplify, you are going to find R. If minus 1000 divided by 2 is 500. This is minus 1000. This is 2000. So F minus 1500, 2000. F is equal to 3500 Newton. This is the force applied by the engine on the car, right? I will give you a recap once again, right? So what they asked was find the force acting on the car in the upward direction due to the engine. When the engine works, like In order for you to move up, the engine should exert a force in the upward direction, right? If not, you can't move up, right? Fine. If that is what they asked, resistive force they give. Reaction acting on the object due to the surface is perpendicular. R naught. Weight. Weight කතාව තමයි. ඔයාලට අවුල් නේ. Like most of you guys might have issues with this weight story. Actually, guys, if you have a weight, any force, okay, this is the weight, right? This is the weight. This was 30 degrees. So you can resolve the weight in their components. mg, if you resolve away from the angle, it is mg sine 30. If you resolve towards the angle, it is going to be mg cos 30. Right? So this is mg sine 30, mg cos 30. So this mg is not there. Instead of this mg only, you marked this and this. So now you have in the upward direction f, the downward direction mg sine 30, the downward direction also r is there. This capital R is in the perpendicular direction. This capital R naught is the perpendicular direction. This is in perpendicular. So perpendicular forces will not come with the equivalent equation because in this direction, for this direction, perpendicular forces will not come. When you resolve them, it's going to be 0. So if all the forces along the inclined plane are marked, mass and the acceleration marked, right? If you simplify this, you're going to get this value. And then this next, they are asking in the B part. In the B part, they're saying find the the second part. Second part, they're saying the car is moving with a constant velocity of 15 meters per second. When the car is moving with a constant velocity, when the what happens? When the car is moving with constant velocity, what is it? Acceleration is 0. Acceleration is 0. If a car is moving with a constant velocity, that means acceleration is 0. So therefore, the same equation, acceleration should be equal to 0. Right? F equals ma. Once again, we apply along the inclined plane. F equals ma. F in this direction minus mg sine 30 minus r, the resistive force, mass into what is the acceleration when the car is moving up with a constant velocity? Acceleration is 0. This whole thing becomes 0 there. So F minus mg sine 30 minus r. So F is equal to what? Mg sine 30 plus r. F is equal to mg is 1000. Sorry, 10,000. Sine 30 is half. Plus r is what? The r is 1000. So you can get the answer simplifying this. There is a question. How did you put 30 degrees? How did I get 30 degrees here? Right, I will show that once again. Right? So this is how I got that 30 degrees. See what happened? This is 30, right? This is 30. This is 90. What is this then? 60, isn't it? Third, like if you consider this right angle triangle, the total internal angles are going to be 180. So this 30, this 90, this should be 60. Once again, here also a triangle is there. If you see, a triangle is there. This is 60 means this is also 60. Vertically opposite angles. This and these are 60. This is 90. This is therefore 30. This is 60. This is 90. This is 30. That is how I got 30, right? Okay, let us go for a small break. I guess this is clear. And let's go for some free body diagrams. Questions are there. And then some complex questions after this, right? 10th question of M13, guys, right? 10th question of M13. 10th question of M13. 10th question, right? This is a question related with pulley system. Actually, the 9th question I will work out in the I will work that 9th question on the tutorial discussion YouTube video, and I'll post it. The 10th question, it's an important question, right? Fine. The figure shows a block of mass capital M that is free to move along a frictionless horizontal surface, right? Capital M is on a frictionless horizontal surface. This block is connected by a massless inelastic cord. This block is connected by a massless, weightless inelastic cord that passes over a frictionless pulley to a mass simple limb. Get an expression for the acceleration of the system and the tension of the cord. We need to find the when you release that system, we need to find the acceleration of the system and the tension of the cord, right? Okay, let us see. Initially, let us draw the figure, guys, right? Okay, this is the pulley, right? Okay, it's there on this, and then it's like this. Right. It's going to look like this. All right. System is this. So what is the mass? Capital M. This is simple M. So before you attempt an F equal ma question, before you attempt a Newton's laws question, make sure to mark all the possible forces first. Mark all the possible forces of the system first, and then start to proceed, right? So, okay, initially, there's going to be the weight of this capital M. Weight is going to be there, weight, mg is there. And then, since this object is in contact with a surface, a reaction force will be there perpendicular to it. And then also, a tension force, since the string is stretched, a tension force, T, right? One important thing is they have told there is no frictional forces. Frictionless surface means no frictional forces. Frictionless, right? And then the weight of this simple mg, the weight of this simple mg, and then this tension. Since, okay, you need to understand one more thing, well, since this string is the same string, since this string is uniform, since this string is light and inextensible, this is T, this is T, like the tension is going to be uniform, right? We learned this. If the string is light and inextensible, then the tension along the string is going to be the same, uniform. Method T. The direction depends on, like, okay, this pulls down, therefore this is upwards, so therefore this is downwards. This is pulled in this direction, so T in this, right? Fine. So I think we have marked all the possible forces of this system. Now, what do they ask? They are asking, when you release this system, find the acceleration that the system would move with. Right. Now, guys, think about this in this way. When M moves down, this capital M also should move in the same amount, right? Like if simple M is moving downwards, if simple M is moving downwards by a certain amount, capital M is also moving in the right direction, in the same amount, right? That's obvious because it's connected with an inextensible string. So therefore, this is a well-known thing, right? If this mass travels with an acceleration a, then this also travels with the same acceleration a. This should make sense, right? Because මෙයා යන ස්පීඩ් එකෙන්මයි මෙයා යන්නත් ඕනේ. දැන් හිතන්න මෙයා යනවා මේ like assume that this is going with a speed of 100 meters per second and this is moving with 10 meters per second. Can that happen? This is going with high speed, this is slowly coming. The string is going to detach, disconnect වෙනවා. එහෙම වුත් එහෙම. ඒ මෙයාගේ ස්පීඩ් එක මෙයාට match කරන්න බැයි නම් the string would detach. So therefore, always the speeds, accelerations, all these things of both these connected objects would be the same. If this guy has an acceleration a, this should have an acceleration a as well, right? Okay, fine. Now simply, in order to find the acceleration, we have to apply F equals ma. We have to apply F equals ma, right? Okay, let's do it. Let us apply F equals ma initially to the capital M object. Let us initially apply F equals ma to the capital M object. To the capital M object, we are going to apply F equals ma in the direction that it moves. It's moving in which direction? Towards the left. So therefore, towards the left, I'm going to apply F equals ma. What is the force in this direction? What is the force acting towards the left? Capital T. What is the force acting on capital M towards the left? මේ system එක මත මේ පැත්තට act කරන force එක මොකද්ද? Capital T. Is there any other force? Is there any other horizontal force? Is there any other horizontal force? No. Equals, what is the mass of this? Capital M. What is the acceleration acting on this object? A. This is one equation. This is one equation. Let us once again apply F equals ma to this object. Simple M. Right? Let us apply F equals ma to this object. Simple M. So for simple M, we are going to apply F equals ma in the downward direction. Why? Because simple M is moving downwards. Simple M is moving downwards. Therefore, we are going to apply F equals ma to the mass simple M in the downward direction. Right. Okay. What is the downward force? mg. What is the upward force? Minus t. Upward force is minus t. Downward force is mg. What is the mass of it? M. What is the acceleration? A. This is the second equation. So actually, we have two equations, two unknowns. T දන්නෙත් නැහැ, A දන්නෙත් නැහැ. මෙතන T දන්නේ නැහැ, A දන්නේ නැහැ. We do not know the tension as well as the acceleration. We do not know both these things. We do not know the tension. We do not know the acceleration. Right? But capital M and simple M is known. Therefore, what we do is, in order to find the acceleration, I'm going to add these two equations. If I add these two equations, this T2 minus T would get cancelled out, and I'm going to get an answer for the acceleration of the system. So once I find the acceleration, I'm going to substitute it here, and I'm going to find the tension, right? So yes, I'm going to add the first equation and the second equation. If I add the first equation and the second equation, what happens? T plus mg minus t is equal to, like, the left hand sides are added, this added to this. Right hand side should also be added, capital MA plus simple MA, right? T2 minus T cancels out. T2 minus T cancels out. Mg is equal to MA plus simple MA. We need to find A, right? What we need to find is A. Let us take A out. Capital M plus simple M over Mg. Capital M plus simple M over Mg. A is equal to Mg M plus simple M, right? This would be the answer. This would be the answer for the acceleration. This would be the answer for the acceleration. And also they have asked us to find the tension of the system. They have also asked us to find the tension of the system. So how do we find the tension now? Actually, we have found the acceleration. If we apply the acceleration here, can't we find the tension? Pretty simple, right? We can easily find the tension if we apply the acceleration here. So I'm going to consider the equation 1. I'm going to consider the equation 1 and I'm going to apply, okay, capital M into what is acceleration? Acceleration is this. Mg M plus simple M. So the tension is what? M simple Mg M plus simple M. M plus simple M. Right. We have found the acceleration and also the tension. It was quite easy, right? This is very easy. You just have to apply F equals ma to the objects individually and obtain two equations, and you need to add them. If you do not have the mathematics knowledge well, then it would be difficult for you. It would be definitely difficult for you, right? Okay, right. Simply, I first of all applied for the capital M object F equals ma in the direction that it moves, because when you release it, this is going to go down. This is going to go in this direction. So I assume this is going to go down with acceleration a, and I assume this is going to go in the same acceleration a, right? So for this object, capital M, I applied F equals ma in the forward direction. So what is the only force acting on the capital M? T. There is no other horizontal force. If you see this, there's no other horizontal force. So T. The mass is capital M. Acceleration is a. So for simple M, since it is moving downwards, I applied F equals ma downwards. What is the downward force? Mg. What is the upward force? Minus T. The mass is simple M. The acceleration is a, right? Therefore, I added both this equation and then I cancelled T and got an expression for A, and I substituted A here and got an expression for T, right? So actually mass means like it's mass. Actually, what we need is not the mass, the weight. Weight means mg. Weight means mg, not m, right? M is mass, weight is mg, right? Usually සාමාන්‍යයෙන් බර කියලා කියන්නේ weight එකට, mg, right? Not simple m. Therefore, like we mark it as the force. The force of the weight is going to be mg. Mg, mass into gravitational acceleration. Mass into gravitational acceleration, right? Due to gravity on each object of, like, actually we have done these things previously, but instead, since you asked, I'll say, if you consider any mass object, due to the gravitation acceleration on that object, a downward attraction force will act by the earth core. That is considered as the weight of an object, right? We have discussed these things clearly in linear in the motion under gravity part, I guess, right? So Yes. Right. So I guess that is understood. And then they have given the masses. They have given the values of capital M and the values of simple M as 3.5 and 6.5. And they are asking you to find the tension, right? So tension and the acceleration, you just have to substitute. You just have to substitute for simple M 3.5, for capital M 6.5. These are pretty easy stuff. So therefore, I'm not going to waste time on that, right? So you have to analyze this well, right? You have to analyze this well. I will take a picture of this and I will move on, right? So after the class, analyze it well, right? All right. So let us move on to another question. Right. The 11th one is kind of the same question. The 11th question is the same question, and the 12th is also kind of the same. So 11th and 12th I will discuss in the video, right, separately. I need you to move on to the M14 tute. M14 tute. Here, in the M14 tute, we need to draw the action reactions of these free body diagrams. They have given few diagrams. We need to draw the free body diagrams. They have given few diagrams. We need to draw the free body diagrams. Right. Let us draw it. I'll erase this. So read the M14 first question. Right. M14, first one. What does it say? Draw the free body diagrams and mark all the reactions on each of them. Mark all the reactions. Assume that the surfaces are smooth. If the surfaces are smooth, that means there's no reaction, friction. There's no friction, right? So this friction story we will learn in the future, right? So after this lesson, next we have to discuss force and momentum change, and then thereafter friction, right? So yes, we need to draw the free body diagram. They in the small figure they have given, the small figure. Usually when a question is given, they have given a small figure and a large figure, right? Small figure is the figure where it is touching. They have drawn the small figure. These points are touching each other. But the large figure, they have given contactless in order to draw the free body diagram. Contactless. On this figure only, you have to draw the free body diagrams. You can't draw the free body diagrams on this because it's touching the surfaces. So here, contactless they have given. All right. Okay. Let us see. Let us see this. Now, there is two walls. Two walls are there. Two walls are there. On two walls, there is a rod. There is a rod placed in this way. I have drawn it in contactless manner, right? එන්න මේ විදිහට රොඩ් එකක් හේතු කරලා තියෙනවා. මෙන්න මෙහෙම රොඩ් එකක් හේතු කරලා තියෙනවා. We need to draw the free body diagram. We need to draw the. We need to mark all the forces acting on this rod. First and foremost, its weight. Bar, mass, its weight. Its weight is going to act, right? So its weight is going to act at the center. Right, weight is marked. What else? Now what? There is a contact surface here, right? There is a contact surface here. There is a contact surface here. If there is a contact surface here, definitely there should be a reaction acting on the object by the surface. If there is a contact surface, then there is a reaction acting on the object from the surface, and that reaction should be perpendicular. That reaction should be perpendicular, right? Let us mark it. R, the reaction R. This is the surface. To the surface perpendicularly on the object R. What else? Once again, at this point also there is a reaction. Why? Because there is a contact surface. Here also there is a contact surface. Since there is a contact surface at this point, a reaction will act on the rod. In which direction? Perpendicular to the surface. Perpendicular to the surface in this way. S. Is perpendicular. Isn't it? This is the surface. The reaction is perpendicular to it. Right. This is the only possible. These are the only three possible forces that acts on this object. There is no any other forces because there's no friction here. They have told the surface is smooth. No friction here, smooth surface. They have told it, right? So therefore, the first question is done. First one is done. Let us go for the second one. Let's go for the second one. It's quite, will be somewhat tricky. The second one, we need to analyze it well, right? We need to analyze it well. Right. There is a ball here, another ball here. We need to draw such that it doesn't have contact surfaces. Right. Do not worry about the symmetry, right? Just assume it's a symmetric figure. These are three spheres. Let's assume three spheres. First and foremost, what do you have to mark? The weight. The weight of the object. You have to mark the weight of the object. Right, let us mark the weight of the object. We do not know whether they are the same weight, right? We do not know whether they have the same weight. Therefore, I'm going to mark this as WM1G. They have not told anything, right? So therefore, I'm going to consider this as M2G, M3G. Right. The weights are marked. The weights are marked. Now let us step by step mark the reaction forces. There's plenty of contact surfaces. If you see, there's plenty of contact surfaces. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 contact surfaces. Which means in all these contact surfaces, we need to mark the reactions. Right. Let's consider the first contact surface. Somewhere here. So this is the surface, perpendicular to the surface. There's going to be a force. I'll mark it as R1. Once again, there is a surface here perpendicular to this. That's R2. R2. This is R1, R2. Perpendicular, right? Once again, contact surfaces. This is the object. This is the surface. Now the surface is circular, isn't it? The surface is now circular. Usually when the surface is circular, what do we have to do? Like when the surface is circular, how do we draw a perpendicular line to a surface which is circular? What we do is, we first of all draw the tangent to that surface. We draw the tangent to that surface. We draw the tangent to that surface. And we need to draw the perpendicular line perpendicular to this tangent. The reaction will be perpendicular to this tangent. R3. Perpendicular to this tangent. R3. R3. Now you need to be very careful. This is one single contact surface. The force acting, the reactional force acting on this object by this object is R3. The reactional force acting on this object by this object is R3. What can you say about the reactional force acting on this object by this object? What can you say about the reactional force acting on this object by this object? It is action-reaction. Action-reaction. R3. 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 This R3 and R3 are action-reaction pairs. This R3 and this R3 are action-reaction. One single contact surface. So we broke it to two. One action pair is here and the other action is here. Action-reaction. Right? Usually, you remember, right? So when this is the surface, okay, this is R. Then on this R, there was one single contact point. Here there is one single contact point. The reaction on this object is R3. The reaction on this object is R3 in this direction. The two reactional forces are equal in magnitude, opposite in directions. Opposite in directions. Right. Okay, fine. Now what? Now what? That is done. Now let us go for this contact surface. Because all the contact surfaces of this circle, this sphere is completed. 1, 2, 3. Now let us go for this contact surface. R4. Perpendicular. This is the surface. This is the surface. Perpendicular to that surface. Reaction was R4. Right. Once again, there's another contact surface here. What can you say about it? So, yes, draw the tangent line. On this object, by this object, the reactional force is acting in this direction, R5. On this object, by this object, reactional force is acting on this side R5, 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 R5. Action reaction pair. One single contact surface on this object by this object, the reaction is acting in that direction. On this object by this object, the reaction is acting in this direction. And also there is a contact surface. So if there is a contact surface, R6, contact surface R6, R6. So this is how you are going to mark all the possible forces or else the free body diagram of this system. Free body diagram of this system. Right? Okay, right. So let us go for another one. The second one. So no worries, right? You need to analyze it like leisurely. Try to understand it leisurely. Right? Do not have a rush. Leisurely try to figure it out. All right. Now I will go for the next one. That is the same. The third one is it's going to be the same thing that we did. No, not the same. There is 3 surfaces. The third one, there are 3 surfaces. This is one rod. On the rod, then there is a hemisphere, and then on the hemisphere, this kind of view, right? This is how it's going to be. The third one, the third figure. So first of all, let us mark all the possible forces. Before that, we need to mark the weights. M1G, maybe here M2G, maybe at the center M3G, right? All the weights are marked. All the weights of 3 different objects are marked. Now what? Now you just have to mark the reactional forces. You just have to mark the reactional forces. So how many contact surfaces are there? Right, here 1 contact surface, 2, 3. 3 contact surfaces are there. 3 contact surfaces are there. First of all, I will find this contact surface. R1 perpendicular. R1 perpendicular. On this object, on this rod, by this rod, R1. On this rod, on the horizontal rod, by this inclined rod, R1. Action reaction. Newton's third law. Newton's third law. Contact surface. R2. R2. Right? R2. R2. This is the object, this is the surface, perpendicular. This is the surface, this is the object, perpendicular to the surface. Right. Next, this surface. There is a contact surface at this point. Right? So if we consider the rod initially, if we consider the rod, or else if we consider the hemisphere as the object first and the rod as the surface, if you consider the hemisphere as the object first, if you consider the hemisphere as the object first, right? Then the reaction on the hemisphere will act on the hemisphere perpendicular to the surface. R3 perpendicular to the hemisphere surface, the rod perpendicular to the rod surface. Then therefore the force on the rod will be perpendicular. The force on the rod, the reaction on the rod will be opposite to the R3 because action reaction pair, right? Action reaction pair. All right. So this is how it's going to be. It's going to be. All right. So I think I will not be drawing all the rest of the things, right? So I think more than 3 is enough. The rest of the stuff, of course, you will have to draw. Was this clear? I guess. Was it clear? Yes. All right. Others, was it clear? The action reactions, the how to mark the free body diagrams. Yeah. All right. Okay. All right. Fine. Nice. Okay. So, fine. Nice, guys. So the rest of the 3, 5, 6, 7. 4, 5, 6, 7. Try to draw it on your own. I will include them in the discussion as well as a help. All right. So before I post the discussion in the YouTube, try to do it on your own and try to and then check with my answer that I post. Right. All right. Okay. So let us go for the next question. The third one. The second one, let's go for the third one. M14, third question. I'll take a picture of this, right? M14, third one. Right. I'll erase this. M14, third one. I've taken a picture of this. I'll post it in the group, right? You can later clearly note them down, right? Okay. What does it say? Find the reaction. Find the reaction between each of the blocks in the following. Assume that all surfaces are smooth. What are they asking? Find the reaction between each of the followings, right? They're asking us to find the reactions on each of the followings. Right. Right. Third one. It's like this. There is a mass capital M, and also let us draw the other mass without any contact, right? Let's draw the other mass without a contact. Right. And then you are applying a force capital F. You're applying a force capital F. Right. Okay. Right. They are asking you to find the magnitude of the reaction. Although in the question they have not clearly told it. In the question they have not clearly mentioned as find the magnitude of the reaction. So find the reaction means you have to find the value of the reaction in terms of Fm simple M. First of all, before we try this kind of a problem, what do we have to do? We have to mark all the possible forces. First of all, mark all the possible forces, and then only you have to think what you can do. Right? Because when you mark all the possible forces only, you will actually see something. You need to start from here. At least like some kind of an idea would be it would come into your mind when you just look at the like mark all the forces, right? Let's mark. Weight is there definitely, right? Okay. Capital Mg, simple Mg. Right, and then what? So since there's a contact surface between these two, there's going to be a reaction force R1. There's going to be a, since there's a contact surface between these two guys, there's going to be a reaction force R2. Since there's a contact surface between these two guys, there's going to be a R3, 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 R3. How do we find the magnitude of R1? How do we find the magnitude of R1? It's pretty simple. Consider only the M object. Consider only the M object. This is why they ask you to draw free body diagrams, right? When you draw free body diagrams, you can break it and analyze. Consider only M. You need to find R1. The R1 is an upward force. Let us apply F equals MA for M object, F equals MA in the upward direction. This is actually pretty lame, right? So once we study equilibrium and all, we can easily find R1. But for the time being, let's apply F equal MA since we have not learned about equilibrium yet. F equals MA. What's the upward force? What is the upward force acting on capital M? R1. What is the downward force acting on the capital M? Mg. Minus Mg therefore, right? Since it is downward, minus Mg. Its mass is capital M. What is the acceleration in the upward direction? Is the object moving in the upward direction? No, guys. It's moving only in this direction. Due to the application of force capital F, the system is moving in the horizontal direction. It's not moving in the upward direction. Which means the upward acceleration is 0. Therefore, R1 is equal to Mg. You can easily get this using equilibrium, but since we have not yet learned about equilibrium, it's quite difficult. I did not want to include that here. Right, R1 equal Mg. So similarly, if we apply for simple M, F equals Ma upwards, upward force is what? R2, downward is Mg, mass is simple M. What is the upward acceleration? What is the upward acceleration on simple M? 0. So R2 is simple Mg. So we have found R1 and R2. Now finding R1 and R2 is not going to be a big deal. Okay, I will explain from the beginning. Right, okay, fine, it's fine. Simply, they're saying they have given two figures, a mass capital M and another mass simple M. Now both of them are touching together, touching each other. And then you are applying force capital F. When you apply a force capital F, what they are asking is find all the possible reactions, find the magnitudes of all the possible reactions. So for us to find the magnitudes of all the possible reactions, first of all, we have to mark the reactions. Yes, so what I did was, here there is a contact surface. Therefore, the reaction will act on the capital M, R1. Here, there is a contact surface. R2, perpendicular to the surface, R2. Another contact surface is here. Another contact surface is here. Therefore, I'm going to apply at a contact surface. If you consider this object, the reaction of this object is perpendicular to the surface of this. If you consider the reaction of this object, it's going to be perpendicular to the surface of this. And also, since this is the same contact surface, both are going to be action-reaction, the same magnitude, opposite directions. They're not simply asking us to draw the reactions. What they are asking is us to find the magnitude of the reactions. You have to find the magnitude of the reactions. Therefore, what I did was, first of all, I need to find R1. Therefore, what I considered was, I considered only the capital M object. I considered only the capital M object. Forget about this simple M. Forget about this simple M. Forget about the ground. Consider only the capital M. And I applied F equals ma in the upward direction for capital M. For capital M, I applied F equals ma in the upward direction. What is the upward force acting on capital M? R1. What is the downward force acting on the capital M? Minus mg. Because we are applying the equation upwards, so the forces in the upward direction are plus, forces in the downward direction are minus. Pretty simple. What's the mass? Capital M. What is the acceleration? In the upward direction. Acceleration in the upward direction is 0. Why? Because the object is not moving up. It's not moving up. It's moving only horizontally. Therefore, can it have an acceleration in the upward direction? No. It should be 0. 0. Therefore, this complete term is 0. M into 0 is 0. Minus mg taken to this side. R1 is mg. Similarly, for simple M also, I applied F equals ma upwards. Upward force is R2. Downward is mg. Minus mg. M0. This goes to this mg. Right, okay. That's quite easy. Next, what we need to find is this R3. Finding R3 is not going to be easy. Why? Because there is an acceleration in this direction due to application of a force. If you apply a force capital F, you know that the object will move. Since this is smooth, no friction, if you apply a force capital F, when an unbalanced force is given on an object, the object will start to move with an acceleration. Newton's second law. Newton's second law. Right? So let us assume it starts to move with an acceleration A. Let us assume it starts to move with an acceleration A. So I need to first of all find this acceleration A. First of all, I need to find this acceleration A. So for that, what I did was, I'm going to consider the complete system. I'm going to consider the complete system. And I'm going to apply F equals ma in the horizontal direction. I'm going to consider the complete system and I'm going to apply F equals ma in the horizontal direction. So for the system, I'm going to apply F equals ma in that direction. Like I told you, right? When we do questions only, you will understand. Okay, this is also possible. Like we can mehema karanna puluwan ganak. And eheme a mindset again when you analyze questions, right? We can't teach all these in theory, right? Theory just F equals ma. What we can do from F equals ma should be analyzed in questions. That's why I told these things are important. Right? So we can consider the complete system and we can apply F equals ma. When we consider the complete system, what is the horizontal force? Capital F. On the complete system, we are supplying a force capital F. Right? When you consider the system, the ground is not going to come, right? Remember, ground is not going to come. Both these objects. If R3 also going to come, right? R3 is in this direction. Minus R3. On this, R3 is on that direction, R3. Here. Because when you consider the system, both these objects include, we need to consider the forces acting on both these objects when you consider the system. But R3 to R3 cancels out. See, R3 acts in this direction. Here R3 acts in the other direction. Equal magnitudes. Magnitudes are equal, opposite in direction. Magnitudes are equal, opposite in direction. Cancels out. They get cancelled out. We call them as internal forces. Here, R3 is an internal force. Internal force means it's actually a reaction. But when we consider the system, this R3 to this R3 cancels out. If you need, you can write it and move on. Okay, in this direction R3, in this direction R3 it seems, but it's a waste of time writing, right? Writing them is also going to take a millisecond, right? Even that is going to be important for us. So I'm going to neglect it. I'm not going to write it. It's going to get cancelled out. This R3 to this R3 is going to get cancelled out. Therefore, is there any other horizontal force acting on the system? No. What is the total mass of the system? What's the total mass of the system? Capital M plus simple M. The complete system is moving with what acceleration? A. A. Now we can find the acceleration. Acceleration is equal to F over M plus simple M. Acceleration is equal to F over M plus simple M. Now we have found the acceleration. Now what? Now, what we need to find is R3. What we need to find is R3. So what I'm going to do is, in order to find R3, if we consider the system, R3 is not going to come into the equation, right? So therefore, what I'm going to do is, I'm going to consider only simple M. In order to find R3, the magnitude of R3, I'm going to consider only simple M. Let us consider simple M. Let us consider simple M, and let us apply F equals ma horizontally. Let us apply F equals ma horizontally. What is the force acting on M, simple M? What is the force acting on simple M? R3. R3. Is there any other force acting on simple M? Is there any other force acting on simple M? Any other horizontal force? No. There is no any other horizontal force. So R3 is equal to, what is the mass of simple M? M. What is the acceleration of simple M? Same acceleration, right? How do I say same acceleration? Because if this is simple M, if this is capital M, when both are moving with A, if the complete system is moving with A acceleration, that means this guy is also moving with A acceleration, right? It's moving with A acceleration. Pretty simple. A. So R3 is equal to M. What is A? That is why we found A. By considering the system and by applying horizontal equation, that is why we found an expression to A in order to use it here. R3 is Fm M plus simple M. Fm M plus simple M, right? Okay. This is how you do that. Was it understood, guys? Was it clear? Do you have doubts? Was it clear, guys? Do you have doubts? Right. Okay. Seems like it's clear. All right. So fine. I'll take a picture of this as well. Right. Okay. Fine. Right. Nice. Okay. I'll just give you a hint of how to do the third one. The third question is the second question is the same. I'll give you a hint of how to do the third one. You can try it on your own, right? I'll just draw the free body diagram of the third one, right? Right. Actually, this is how you do it, right? The third one, this is 2m, and this is m, and then this is 3m. This is 3m, right? So you're applying a force capital F. So 2mg, mg, 3mg. The reactions R1, R2, R3, there's a contact surface, R4, R4, R5, R5, right? So you know how to find R1. R1, of course, apply upward F equals ma for one single object, and fine, R1 is going to be 2 mg, right? R1 is going to be 2 mg, R2 is mg, R3 is 3 mg, right? So first of all, what you need to do is you need to consider the system. You need to consider the system. You need to consider the system and apply an F equals ma in the horizontal. Let's assume this is moving with a acceleration. Let us assume the system is moving with all the complete three objects are moving with a acceleration. And okay, so what is the force? Capital F. R4 internal, R5 internal. When we consider horizontal forces, when we consider the horizontal forces of the system, R4 to R4 cancels, R5 to R5 cancels. So what remains is only F. 2m plus m. The total mass is what? 2m plus m is m plus 3m into A. A is equal to F over 6m. We have found acceleration. So if you need to find R5, consider only 3m. Consider only 3m and apply F equals ma in that direction. So R5 is equal to, what is the force acting on 3m? R5 is equal to, what is its mass? 3m. It's also going to move with same acceleration A. So this F into 6m. This to this cancels. So this cancels. R5 is F over 2. F over 2. So you can consider next to this guy only simple m. You can only consider simple m and apply F equals ma. Only apply F equals ma. What is the forward force? R4. What is the backward force? Minus R5. Is there any other horizontal forces acting on M? No. So therefore its mass is M. What is the acceleration? It also moves under the same acceleration. This F06M. This to this cancels. R, what we need to find is R4. R5 we already know, F02. F02. This is F06. Take this to that side. R4 is F06 plus F02. If you simplify, you're going to get the answer. So actually, this is how you do all these problems simply by using F equals ma and reactions. And yes. Now guys, the rest of the questions are also quite difficult, right? So like I'm not going to allow all the rest of the questions to be done alone, right? So we're going to take, I told you, right? The next session will completely be taken for tutorial discussion. For tutorial discussion, a lot of new types of questions are there. A lot of new types of questions are there. The next session will also be completely taken for the tutorial discussion. So please, I guess most of you guys couldn't attend the live session. So therefore, the ones who cover through recordings, please cover it perfectly. And if you have any doubts, you can talk to me anytime, right? Somehow, before you come for the next session, you need to be very fluent on all these concepts, right? And in the meanwhile, try the rest of the two questions as well. I will try my very best to post the questions, question discussions of this tube, M12, M13, M14, M15 and all, right? So remember, next session is going to be tutorial plus past paper question session, past paper question session. So therefore, before you come for the next class, cover the complete Newton's laws of motion and be prepared and get an idea and come, right? Okay, thank you guys. That would be it for today's session. See you on the next week, right? Okay, thank you guys.